but I think if you're building an application, like it just makes it harder on developers to know what's the right thing to do for their application. And when you start building an application, you don't always know what all of the things you're going to need to do. And so if you make some of the wrong choices, that's how you lead to having to do multiple databases. So I believe that there's a benefit to consolidation. Now, from a technical perspective, it's the reason that all these different databases exist is because it's hard to it's hard to build the single database that can do all of these things. It's hard to build a database that can do full text search as well as relational as well as semi-structured. And it's a little bit like, I think when the early days of the sort of the big data era, when big data caused this big freak out and everybody's trying to figure out how they're going to deal with this, with the increase in scale. And there's a couple of papers came out of Google, MapReduce, GFS, et cetera, that allowed people to think about the problem differently. And if you think about the problem differently, then you can actually get better scale.
On this edition of the Data Nerd Herd, I had the pleasure of interviewing Jordan Tigani. Jordan is currently the Chief Product Officer at SingleStore and was formerly at Google Cloud, heading up all things BigQuery. In the data space, Jordan is an OG. In this interview, we cover the notion of one database to rule them all, and how to combine transactional and analytical workloads into a single database. We also touch on data quality, data governance, and much more. Jordan is one of my heroes in the data space, so it was an honor to interview him, and I hope you enjoy it. Thanks.
Hey, Jordan, how's it going?
Hi, great. Thanks. Great to be here.
Awesome. Yeah, cool. So today on the Data Nerd Herd, we have Jordan Tagani. For people who don't know who you are, do you want to give a quick intro?
Sure. Yeah, I'm the Chief Product Officer at SingleStore. I was one of the first engineers on Google BigQuery. I ended up leading the product team and the engineering team at various times at Google. I wrote 2 books about BigQuery, but for the last 18 months have been focused on helping SingleStore become the next great database.
That's so cool. Yeah, I actually use your BigQuery, the definitive guide, in one of my classes, and use BigQuery a ton. So thanks for BigQuery.
Awesome.
In the book. Yeah, that's awesome. That's cool. So walk me through this. I mean, it seems like you got a very deep history in data. Like, how did you get into technology and data in general?
So I started in I was actually an electrical engineering major in college. I got my start at Microsoft working on the helping them figure out how to test stuff that they'd never tested before in the kernel level, the hardware abstraction layer. I worked on a lot of really low level stuff, and ended up at Microsoft Research, working on stuff that would help detect when bad things happened. And we ended up working with some really large data sets because we were taking some like large instruction level traces of what programs were doing. And that was kind of an early introduction into big data. That team actually went on to get reorged into a team that was called Red Dog, and that became Microsoft Azure. And so I could have been there for the dawn of Microsoft's cloud.
Oh, wow.
But then I'm like, oh no, this is too newfangled. It's going to take way too long to get that out the door. And so I left, and I joined a couple startups. One was a very small startup doing ad targeting, machine learning based ad targeting, and also kind of helped me realize that you don't have to be a big company to have large data sets, because we were getting, I think it was terabytes of data per day, and trying to process those terabytes of data per day was a hard problem, and the 2008 or something, 2006. A lot of the sort of the big data tools that we have now were not yet available. Hadoop was sort of just getting off the ground. Then I ended up at Google, and so I was really a big fan of stream processing systems. I think streams are kind of an amazing way to think about data and to think about how think about computation, and it's sort of amazing what you can do in streams. And so I wanted to work on, there was a stream processing tool that Google had. It's called Flume internally. It ended up becoming Dataflow, Apache Beam. Then I got sort of reorged into another, pulled off that to work on a data marketplace. And as this team sat around trying to figure out how to build a data marketplace, we're like, well, we don't want to just have a download link. We want to be able to do something with the data. And SQL is relationally complete, so you can compute anything in SQL, but it's not Turing complete, so at least it will terminate. And so the thing that we built was BigQuery. And so the early days of BigQuery, we were thinking, okay, next quarter we will build a data marketplace. And it took, in 10 years, really, literally next quarter, we would build the data marketplace on top of that. But we had a great ride. BigQuery, went from a sort of this small project with a few users to, a point where it could, if it went down, major banks would not be able to close their books. So it was quite a success story. And so, jumping forward to today, then SingleStore, which was then MemSQL, contacted me about a job. I'm like, wow, these guys look like where BigQuery was 3 years ago. Great technology, doing really interesting hard things, and so I made the jump, and have been we're doing some really cool things, and hopefully we'll be even bigger.
That's awesome. I mean, what's the mission of SingleStore?
The mission of SingleStore is to officially is sort of bringing modern data together. Really we want to be the one database that you're going to need. And there's kind of two ways of looking at it. One is on the analytics side, and the other on the transaction side. Like a lot of people say it's impossible to build a database that can do both transactions and analytics in the same database. I think we can, you can run TPCC on SingleStore, get really great transactional results, and then you can run TPCH, TPCDS on SingleStore, which is basically large scale and complex analytics. So we do have a database that works really well in both cases. On the analytics side, we're really good at fast analytics, low latency analytics, high concurrency analytics, real-time analytics, streaming analytics, those types of things, which are important for a lot of organizations. People that want faster dashboards, they want to be able to make data-driven decisions more quickly. These are all things that we can help you when you come from the analytics side. When you come from the transactional side, there's actually some really interesting space there, because a lot of the things you do in an interesting application, and I mean not just sort of a WordPress simple application, but something you want to build something that's going to do things that are hard. You end up using a lot of databases, and so I noticed this actually when I was at a startup in I don't know, it was 2006, and we started out with sharded MySQL, and single box MySQL wasn't cutting it. We went to sharded MySQL, but there's a lot of types of queries you can't run against sharded MySQL because you can't really do anything that combines the various shards, and so we did all kinds of caching stuff in memory, and then we were using Solr, which is sort of a predecessor of Elasticsearch, and we wanted to do kind of geo search to find restaurants near me, for example. But we wanted also the results to be influenced by who your friends were. So it's kind of a social network plus Yelp kind of thing. That's really hard to do because who your friends were was in a relational database, and then who what restaurants were around was a full text search, inverted index database, and trying to combine those two was incredibly difficult. And so and then of course, like, we're the stuff that the torturing that we were trying to do to the database was all very slow. So we had all this in-memory cache. And, we also wanted to have a flexible schema. So we kind of tried to shoehorn that into the one database, more modern version. We would have used Mongo or something, but like lots of different databases and lots of complexity to try to manage the scale, manage the kind of consistency, cache invalidation, all those types of things. And so SingleStore can be the one database. They can replace all of those databases. So it can do full text search. You can do, large scale analytics. You can do, at a high concurrency. So like applications where you have a user waiting, has different latency requirements than when you're building a report that has to go to your CEO tomorrow morning, or you have an analyst that's sort of like refreshing a dashboard, and it's okay if they wait 60 seconds. But like if you're building an application, you want results in 200 milliseconds, and every 100 milliseconds, actually, you lose some sort of user's attention. And so because SingleStore can, because of actually the architecture, we can kind of deliver those types of things that seem like analytic queries in an application setting for end users, and get those in tens or hundreds of milliseconds. So I guess it was a sort of a long response. Is like, but I think we can help you collapse all of those databases down to one, dramatically simplifying your application. And I think as applications, you want to do more in a modern application. You want to do more stuff. And so if you use SingleStore, then we can help you do that more easily, so you can focus on making your application successful, doing the hard things in your application, rather than figuring out how to make the data fast enough and get the right data that you need in the right place at the right time.
That's really interesting. Yeah, and it definitely kind of speaks to. There's definitely you've hit on it. There's definitely a big argument right now in the data world, like one database to rule them all, or do we just go for a dozen different databases? And I don't know if the argument's been entirely settled yet, but walk me through what are the technical challenges of coming up with a sort of a single point solution for a database that can operate both transactionally and analytically?
I think, there was, you're right that there has been this sort of like fracturing of the database market into like, okay, we have a database for this, we have a database for that, we have a time series database, we have a graph database, we have, all full text search database, you have all these different databases. And I think, Amazon, for example, has made a ton of money selling you like, the tool for the job. You have lots of different, I don't know how many databases they have.
I don't know, hundreds.
Thousands. Yeah, it seems like new ones are coming out every day. But I think if you're building an application, like it just makes it harder on developers to know what's the right thing to do for their application. And when you start building an application, you don't always know what all of the things you're going to need to do. And so if you make some of the wrong choices, that's how you lead to having to do multiple databases. So I believe that there's a benefit to consolidation. Now, from a technical perspective, it's the reason that all these different databases exist is because it's hard to build the single database that can do all of these things. It's hard to build a database that can do full text search as well as relational as well as semi-structured. And it's a little bit like, I think when the early days of the sort of the big data era, when big data caused this big freak out, and everybody's trying to figure out how they're going to deal with this, with the increase in scale. And there's a couple papers came out of Google, MapReduce, GFS, et cetera, that allowed people to think about the problem differently. And if you think about the problem differently, then you can actually get better scale. And the problem was, like, people don't want to think about the problem differently, or it's like thinking about the problem differently is hard. MapReduce helped people, it helped people scale out, but like splitting things into a map and reduce phase, like that's quite difficult. And kind of abandoning the kind of the things that people had been doing, or the ways that people had been doing, was meant that they something was actually lost. So I think one of the things you've seen and certainly on the analytics side is a move away from sort of MapReduce style computation and back to SQL. I think the pure Hadoop is not doing so well, but data warehouses, BigQuery, Snowflake, and even Spark, Databricks, Spark SQL are doing much better, because then people can take the tools that they used and the ways of thinking that they used to use, applying those to large scale data. Now on the database side, you haven't seen that as much. You've seen the initial step, we have to do things differently, the kind of on the NoSQL side, and Mongo, Cassandra, et cetera. We haven't yet seen that people are kind of banging their heads against those and needing something different, except in all these specialized databases. And I believe that the reason that we haven't seen the consolidation is just because the technology hasn't been there to unify those. Whereas on the data warehouse side, we do have the technology and to pull things back into the SQL model, with strong consistency and acid, et cetera. And I think we're just getting the tech that we need on the transactional side. I think the bet that we're making in SingleStore is that there's a desire for not having to do this, and we believe that the tech that we have is strong enough that lets you do those in one place.
That's really interesting insight. So I know in the data world, the common refrain is that data is getting a lot of inspiration from the software world, right? So you get data ops, ML ops, borrowing from DevOps, which is pretty old at this point. But at the same time, it seems like the databases, in the analytics space at least, or there's a lot of evolvement, right? But wait, am I reading you right when you're saying that maybe the transactional side of the house with databases isn't evolving as rapidly as the analytics side?
I think it's not consolidating. It's evolving in different directions, and I think that there's more things that people want to do, and I think there's companies like Mongo have been able to keep pushing evolving the NoSQL model enough to sort of make it good enough that people are sticking with it. But I think you run into sort of architectural limitations, and everybody is slapping on like a SQL-like layer to what they're doing, like some sort of query language. And I think that at some point people are going to start to realize that, hey, these things are like SQL. Why don't we just use SQL? And sort of the new SQL databases, I think are sort of ripe for getting more adoption. And I think there's lots of hurdles that have to be overcome. There's lots of kind of ease of use and kind of developer community integration and those types of things that need to be done. But I think you're right. I think that the transactional side hasn't necessarily evolved at the same pace, or at least it's been sort of a divergent evolution rather than a convergent evolution.
It seems to be too. Like I'm noticing as well, there's also the rise of the data app, right? Data applications, embedded analytics, kind of the whole nine yards. Stuff that it sounds like you're working on in the startup way back in the day as well. But now this is doable and it's happening, right? Applications like I would argue that Uber it's basically a giant data application at the end of the day. So,
sure.
But with the
they're
rise,
they're one of our customers, and I think I think one of the reasons they don't like to use external technology, but I think we've been able to solve some of the data problems that they have been having in a way that they realize would just with enough engineers, any problem is shallow, but like just sometimes it's not worth spending the the time and energy on that. And so they do use us for a bunch of cases where they need high scale, low latency, high concurrency.
Mm-hmm. That's really interesting. Yeah, congrats on being a customer. That's pretty awesome. So, and I guess how does the role of a software engineer evolve then? And I guess the creation of applications where before it was very discrete, right? Like I would have my MySQL database or maybe a Postgres database as a backend, but now there's these analytical applications I can do on top of that. I mean, because traditionally the roles had been bifurcated with software engineer over here, analyst over here. These people don't talk to each other at all. Maybe the analyst asks the software engineer some questions like, why is the data in your transaction app wrong? And they're like, I don't know, you figure it out. You're the analyst. So, and that's traditionally how it's been. And, in quite a few companies and quite a few applications. But now, it's with the rise of data applications, it's sort of, now there's this feedback loop where you have an app getting data, doing something with it, then it goes back into the app. I mean, do you have any ideas of how kind of these roles and their I guess the creation of these applications changes as maybe there's a convergence of these database technologies?
Yeah, I think that that the role of the engineer is going to change a little bit, and I think machine learning is causing that to accelerate. And I think the desire is you want to be able to have your application, change its behavior, but in regards to what is happening elsewhere in the data. And machine learning is a kind of a way of kind of encoding that, where you have a machine learning model that encodes what is in the underlying data. A machine learning model is almost a way of just sort of, it's a data compression or data summarization, and you use that model to sort of impact what you show to the end user. And so I think you saw that first on the analytics side and people wanting to make data-driven decisions. And then you want to be able to make automatic decisions, with data. And then on the application, I think it's also affecting the applications where, you want your applications to be, to behave differently in different data. And just to use an Uber example, like surge pricing is an example where, you're using the state that's going on in the rest of the world to impact what the current user is seeing. And those types of features, are becoming more salient, so it's more important in applications.
That's really interesting. I mean, so there's an analytical side to SingleStore, obviously. With I suppose with the rise of machine learning, is there? Do you see an extension of a database, kind of as a general concept, right? So if we have a transactional analytical, is there a space for machine learning as well within a database, so they kind of all holistically work together? Maybe it's a feature store, maybe it's something else. I don't know. But do you have any thoughts on that?
Yeah, I think that so often the way machine learning gets done is you take your data set and then you export it somewhere into your data lake, and then you have your data scientists kind of like hammering on the data set, and they come up with a model, and then you figure out how to serve that model, and that model lives somewhere, and then your application connects into the model or connects into wherever you're serving, and then you can do kind of real-time inferences. And there's a lot of moving pieces there, and a lot of like places where stuff goes wrong. You have model drift. You have cases where the code that you use to generate your features in order to create the model is actually different than the code you use in your application. And so if you're not exactly doing the same things the same way, you're not actually going to be getting accurate predictions. So I think there's a better way, and I think that SingleStore and with some tech that we're working on can help you offer a better way, which is you can do in database model building, and that's so BigQuery I think was one of the the first modern data warehouses to be able to do in database model training.
Right.
So you can, and then it connects to TensorFlow, and you can do, BigQuery machine learning. You can build a bunch of different types of models over your data without having to leave the data warehouse. So you don't have to, the first step is solved. You don't have to like extract the data somewhere else to do the ML, and that helps you, rapidly iterate over things and try out different feature sets, et cetera. And but I think where a pure data warehouse based machine learning falls short is then how do you get to the serving part? How do you get to
Right.
serving? You can do batch inference, but you can't necessarily do serving. So in a database like SingleStore that can do both transactions and analytics, you could use SingleStore plus some stuff that we're working on that will enable you to build your models in the database. But since you can also use SingleStore as your system of record, as your transactional database, you can do inference in the same place. So it just cuts out a whole set of data movement, of complexity, and of places where things can go wrong.
That's really interesting. Yeah, I mean, I was a bit blown away when BigQuery came out with the ability to do machine learning within BigQuery. I thought that was like really innovative. And in my class, I use it all the time. I'm like, did you know that you could do machine learning in SQL? And people are like, I didn't know that. That's pretty cool. So, but I also realized too, because then my wheels got turning, right? Because in the Google Cloud ecosystem, for example, you have Firebase. And what I noticed with Firebase is, a software engineer could basically package up data warehousing, recommendation engines, machine learning, and like everything in basically one fell swoop, done. Not to say that that's like the end all be all. I more thought of it as like, okay, so if it's going to get this easy to do stuff, I think it's sort of a harbinger of things to come, right? Because on one hand, you have sort of this bifurcation, balkanization of different data technologies and different application technologies. At the same time, Firebase comes along, for example, and I'm like, okay, so that's a one-stop shop. It's a bit simplistic, obviously, and I think it's a starting point. But you kind of fast forward several years and say, okay, so what does the back end of this look like? Like, why would I need to use, Firestore, for example, and BigQuery, like, and serve models? Like, why can't it just all be sort of one thing? I don't know. But then I got thinking, okay, so the pipeline of like kind of a feedback with machine learning back to an app, right? Like that's going to be something maybe a software engineer just takes for granted at a certain point. I think there's a tension between making things easier and making things like work correctly. Because I think one of the problems with machine learning is it's sort of this action at a distance, and like it's hard to debug a machine learning model. Like if the machine learning model is like telling you to do X and X is not the right thing, then it's like, well, why is it telling you to do X? And kind of the observability of ML models is quite difficult. And if the more you're gonna have kind of relying on automation and automatic decision making, you have to make sure that your data is right and that your data is what you think it is, and that makes all these other things like data cleansing and data integrity and observability become all that more important. That's really interesting. I was actually just talking to somebody about data observability right before this recording, and what I find interesting is that the questions that this person was asking was, where does data quality live in the data lifecycle? I made an argument that I think if I had my choice, it would exist at the source, right? But you see all these data quality tools sort of dealing with things after the fact. I'm like, but and the dichotomy right now is that with again, it's sort of the software engineer over here, analyst over here, or machine learning engineer, whatever. But it's like I make the data, software engineer, I lob it over the wall to you, you deal with it, and if it's wrong, that's your problem, actually, because I don't have time to fix it. It seems a bit snide, but this happens all the time. Like it's basically, if you get a software engineer to fix the data at the source, like you're really lucky, is what I've seen. That varies by organization, but walk me through this, because with data observability and quality, and I think just kind of general data management becoming more kind of top of mind these days, how do you do good data management in sort of a like a single store, or just basically a one size database?
It's a great question. I think you mentioned data data quality. Do you solve that at the source or at the destination? The problem about doing it at the source, I agree. If you can do it at the source, it's ideal. The problem is the world changes, and so so if you're let's say you're sending billing information, and you're US based, so everything's in dollars and it's all simple, and then you are you add additional currency support, and so trying to shoehorn that through your system so that like your backend systems don't need to change to support those existing so you're going to be sending new fields, or you're going to be things that used to be null or things that used to be filled out are now null. Like, it's very hard to enforce the quality on the source when the world is changing. I think the way that something like SingleStore can help, and I think there's it gets into the almost religious debate between data lakes and data warehouse kind of type storage, whether you have do you have this like one mess of where you throw all your junk, or do you have like a highly structured data store? I personally believe that sort of the kind of the data warehouse storage versus the data lake storage is the better way to go, because at least it can provide a set of constraints that lets you know when something is, it's much easier to see when something is wrong than in your data lake, where you're just, anything goes. It's a little bit like, I think sort of dynamic typing versus static typing of programming languages. Like, dynamic typing is like, you work, Python, you can send anything you want to a function, and the function may or may not work. But it's really hard to make sure, it's really hard to ensure that stuff continues to work over time, which is, I think, why people generally don't build large scale Python programs, at least for systems that have to work with high reliability. So I do think that the sort of the data warehousing model of sort of strong relational backend is the way to go, and something like SingleStore is can help it be even more easy, because if you're using SingleStore as your transactional backend, you don't have to do ETL to get it into your analytics schema. You just have to do a T, and it's a lot easier to kind of enforce consistency and constraints if you have a single data system than if you have multiple.
That's really interesting. What are your thoughts on data modeling then? I know in the data warehouse world, there's some, I would say, quasi religions that have formed around data modeling, right? So you got Kimball, Inman, Data Vault's increasingly becoming popular too. How does that work in something like a SingleStore? Would I have like my transactional tables over here, then I do the T, transform it into my star schema, and if so, like what does that look like in a system where things are unified? Because if I have my data warehouse over here and I have my source systems over here, I just extract it, load it, transform it within the data warehouse. But like, from a technical perspective to start with, like what does that look like? Does this transformation over here in a SingleStore, does that pose any constraints on the transactional ends over there?
Not necessarily. So I mean, there's a subset of things where actually being able to run queries over, run analytics style queries over the live data is, without having to transform is useful. It's and it depends on how you're building your data model, but often, how many customers do I have? How many, how many things are in flight? What's going on? What's going on right now can be very interesting to run against sort of the live copy of the data. In general, people don't do that because it's if it's nobody wants to slow down or put in jeopardy their system of record that they're running their business on. But with something like SingleStore, you can actually have multiple SingleStore clusters all accessing the same data. So you can have your system of record compute cluster, and then you can have your analytics compute cluster that operates over that data while it's live, but is not going to slow anything down. So that's there's that subset of things where there's sort of not any data modeling going on. But then you can also do, there's a large set of use cases where you do want to have a more regularized schema. You want to show, not just what's happening now, but what is the sequence of things that has happened in the past. And there is some ETL that you need to do in order to do that. And so I think, star schemas are still highly relevant. They're how people want to do things. I think at Google, we tried to convince people at one point that you should denormalize your data, and you can use nesting and arrays to make that easier. And because from the experience internally at Google, basically everything at Google was denormalized into basically a single record type. It was called, I think it's Gwistlog Proto or whatever, but I think it had several million fields.
What?
It was a mess. But it's like, yeah, you can denormalize everything into one. It's not always, it makes the processing a lot easier because you can just do things in a single.
Yeah.
The thing is, the world didn't want to go that way. Like the world, I think that the world wants like a Kimball, wants a star schema. They like slowly changing dimensions and all that stuff. So that isn't going away. And I think the nesting and repeating, while it's great from a technical perspective, it makes things like connecting your BI tool a lot harder because Tableau doesn't know how to deal with a nested schema and
right,
and the kind of the funky SQL that you have to generate to do even some simple things.
That's such a good point. I do remember when BigQuery came out, and I was evaluating it back, and must have been the early mid 2010s. I can't quite remember, but at the time I was like, okay, what is this? It's almost a data warehouse, but I'm not sure how I would describe it. It's very googly, if you know what I mean. So I think Google, to be fair, Google, I think that the technology Google makes is amazing. Google Cloud has, and Google internally, I'm sure they have some science fiction level tools. But the way it was marketed it's like, I don't get it. And the same way, App Engine was the same way when that came out. I remember looking at that in the late 2000s or 2010 or something, and I was like, I think I understand what this. It's kind of like Heroku, but it's not, and I don't know what. And I'm like, I'll just get a VM. This doesn't make any sense to me, right? Because it was like by the time I use this, I'm like, this has too many handcuffs on it. I kind of want the flexibility of a VM. Now, obviously, things are changed, and but I felt the same way about BigQuery. It seemed like, okay, if it's good enough for Google, it's good enough for me. But I just don't know what this is supposed to do. And then the white denormalized thing threw me off because I was like, well, but everyone wants a star schema because that's what you're supposed to do in a data warehouse, right? You pull my star schema from my cold dead hands, kind of, to paraphrase something. And that's the feedback I got from other business users as well and analysts. Can I do a star schema in that? It's like, I don't know. They say it's white and denormalized, so maybe. So
yeah, it was trying to convince some of the engineers that joins were important was very difficult. If that's, that was many years ago, and I think at the point we realized, hey, what we have is almost a data warehouse, just like what you said. And if we add these things, we can be a great data warehouse. And I think that was a big turning point in BigQuery. And I think, it's sort of like I see is similar to SingleStore. So BigQuery, we had this amazing tech, and we knew that we were solving something. We knew that there was something there, and it needed a couple of tweaks to make it sort of universal, and then to also be able to solve not just the data warehousing problem, but I think BigQuery was one of the first data platform. Everybody else started calling their data warehouse a data platform, because there was an underlying problem that's broader than a data warehouse that I think BigQuery was solving. And I think I believe SingleStore is in that same pattern, as a sort of, there's an underlying problem that we can solve of sort of data intensity, and that goes beyond pure analytics and pure applications.
Mm-hmm. Yeah, that's really interesting. And I've also found too, it's like, I think that with a lot of companies, the technology's there, but it's also just the messaging, right? Because you're trying to advocate to a broader community. You have your internal advocates, and you guys will pat each other on the backs all day. It's like, yeah, we got the best tech ever. It's great. Yeah, I know we're killing it. But then you get to the real world and market it, and then people are like, you either get it or you don't, right? I think like Snowflake did a really good job where they knew how to sell the enterprise. They had a data warehouse. They just, it was like, it's a data warehouse. We're going to replace Redshift. And people are like, thank goodness you're going to do that. So, and they killed it with that. But I noticed that just, it's one thing to have the tech, but also the messaging behind it, getting the community kind of rallied around it. Like that's also a big challenge. I was talking to somebody at, a friend of mine who works at a tech startup the other day. They do data products, and he's like, yeah, we have this amazing team, we got the amazing tech, but it's the real challenge isn't that. It's like, just how do you get people to get on board with your message and what you're trying to do? I don't know if you have any thoughts around that, but
I will say that was one of the things that was most surprising to me coming from Google, is just how much harder it is to get your message out and to kind of get awareness and just because at Google Google didn't even spend that much money on marketing. It's just the fact that it's Google, kind of people took it seriously. And I think if you're a startup, people don't always take you that seriously. And so things you kind of take for granted at a larger company can be a lot harder. And so, I mean, I think that's one of the things that, we raised funding, last summer when we didn't necessarily need more money, but we're like, we want to, we think we've got an amazing product that's relevant to a huge swath of users, but we have low awareness. And so let's focus on demand generation and marketing and awareness generation, so that we can tell the world how cool the stuff that we've built is and how useful it is.
Right. Makes a lot of sense. Yeah. I'm not sure if you saw Matt Turk's data landscape slides. Every year he has like the 2021 version, the 2020 version. And I think it started with the 2012 version, which was, it's just a kind of a landscape of logos in different verticals and stuff. But I remember the 2012 version was like, that was big, but you compare it to now, and there's just a lot of companies in the data space doing, and the crazy thing is like, they all have the pedigrees you'd expect. Like I went to Stanford or someplace and did computer science, and I went to, I would call it a FANG, but I don't know what it's called anymore, because Facebook changed their name and so forth. But then everyone raises a lot of money, and then it's kind of like, okay, so like how it's just competing in this current landscape is, it's definitely challenging for sure. And so, like, I don't know if if the playbook needs to be rewritten, or if it just, or what, but it just seems like it's definitely a big challenge these days for anybody trying to compete in the tech space. So
sure. I mean, we just had a pretty big win. We got onto the new Gartner combined cloud database Magic Quadrant, and so that was, there's 20 companies, winnows down the large data space to 20 companies, and that just sort of, I think, gives a lot of enterprises kind of permission to buy your tech. So I think that helps from the awareness side.
That's cool. Congrats on that, by the way. I saw that. I saw you posted that, and that's really awesome.
And I also think partnerships can help as well. Like you kind of hook yourself to the right partners, and you can win together, and you can have a 1 + 1 = 12 kind of thing.
I think partnerships are definitely key. We partner with a lot of companies, and it's just one of those things where I feel like going to bat for the companies we work with, and they go into bat for us. Just it tends to have a good synergy, and it's important these days just because there is so much competition. And it's interesting too. Like I look at the observability space, for example, and it seems like every day somebody has an observability company that's just launched, and cool. So now it's like 1,000 companies or something. I don't know, but I hope everyone does really well. I mean, the nice thing is the data space. I think it's still as long as it's been around, it still feels like it's early days, and it feels like there's a lot of rejuvenation in the field. Like, the cloud's still in early days too. I think depending on who you talk to, the cloud, like companies that have adopted the cloud are like anywhere from 10 to maybe 30%, if even that. So depending on who you believe, some people say it's 100%, but I think that includes like using stuff like Gmail or something, which doesn't, in my opinion, really count. So, but yeah, I mean, what are your thoughts on something like the modern data stack, for example? Do you have any opinions on that?
Yeah, I mean, I think the modern data stack, is people are saying, DBT, like Fivetran, DBT, Snowflake, and I think that, I think we are still in early days, and I think Snowflake is sort of taking an early lead. Databricks is sort of out there saying that they are, they want to go head to head against Snowflake. And I think at SingleStore we want to approach it from a kind of a slightly different direction. Like the data warehouse is still not the way that you want to build your applications. Like, I think, and if end users are hitting your data warehouse, then in generally you're doing something wrong. And so we want to approach it from that perspective, and sort of like, okay, yes, there's a modern data stack over here, but we want to be able to augment that with with some of the stuff that we're doing, and not necessarily say we're gonna go head to head against Snowflake. We don't want to play on their turf. We want to sort of change the game. We're going to be over in making your applications faster.
That's a good point too, because I think the thing that's missing from the current modern data stack paradigm is a lot of these data warehouses aren't made for like true real-time data applications, like low latency queries. Like, when we work with Snowflake, but I wouldn't necessarily recommend that a customer put that up against like a real-time dashboard where it's getting pinged by millions of users at the same time, because it's going to get very expensive unless you have the budget for it, in which case, like, go for it. I'm sure Snowflake would be very happy to, for you to do that. But, a lot of companies don't have those kind of deep pockets either. And so, it does require a lot of finesse right now. And there's definitely some great point solutions out there. You could go with like a Rockset or a Pino or, Imply, but again, you still have to get your data in.
Yeah.
Right. And that's kind of the challenge. And then how do you do this right now? You can do it event-based, or you can do it change data capture. And these are all paradigms that are definitely growing in scope. But I think what you're kind of saying is, well, what if it's just all in like the same spot anyway? Then you don't need the pipes, right? So
yeah, and I mean, we work really well even if you don't. I mean, we do, we have really high speed ingestion. We can do, I remember at BigQuery, we were very proud that you could do, BigQuery streaming. You could do, we can stream like a gigabyte per second into a table. But those were all appends. And so like appending to a table is, generally pretty easy. You just, you think about it, you write to the end of a log. SingleStore can do that scale or more, but updates. Damn. And that's really hard, because you have to find what, find the row and update it. And it's not just an append. You either have to do it at you do it at, you could do it at insert time, or you can do it at query time, or a mix of the two, but still it's still a lot harder. And so SingleStore is very good at getting data in quickly and updating it.
That's impressive. So it almost defies some laws of physics. So it just sounds awesome. So that's really cool. I guess where do you see the world of data in general going over the next 3 to 5 years? Kind of a broad question, but I'd like to ask it.
I think I would say this data warehouse storage versus data lake storage my prediction is that's going to be resolved in favor of the sort of the data warehouse style storage where you have a relational data store. I think a lot of people have, giant data lakes, and I don't think they like them. So when I was at Google, we had a customer advisory board that was actually it was some of the like CIOs, CTOs of Fortune 50 companies. So some of this was actually the room that I was in was like, I think probably the most high powered room I've ever
Oh, wow.
been in. And so we were, was talking to them about, data and we had somebody at Google who was interested in a Google Data Lake product. And so we were trying to push Data Lake on these guys or these folks, and they and so I asked, so what do you think about data lakes? And like that was the one thing they all agreed on is like, I've got a data lake and I hate it. It's like, and it's like, oh yeah, mine's a data swamp, and mine, it's like we want to go in the opposite direction. And yes, that was, there were some failures of technology, but I think one of the problems that a data lake is it ends up being like this dumping ground for everything. And, I think that the lake house I feel like it's a clever hack that makes your data lake less like abominable. But I also think that it's, when you get into things like, you want better governance, you want to have, fine grain access controls, you want life cycle policies, all these things become much harder to do, and data, and you want data to be, fresher and updated faster. All these things are really hard to do in a lake house if you're, in something where you're constrained to give people access to physical files. Because if you give people access to physical files, then you can't say this user is only allowed to see this field, or this user is only allowed to see this rows because they have the file, like they can read the data. And yeah, they're goofy things like Ranger and things you can put on top of that. But I feel like these are sort of hacks that are trying to fix an underlying broken model. Whereas, kind of in a data warehouse, you can, you're giving the abstraction you're giving people is not a file abstraction, it's a table abstraction. And you can do a lot, in that to give people reliable, correct, and highly governed data. So I think that's sort of my one prediction, and I think that a lot of folks would disagree with me on that one. But I think if you think about it, like the whole reason a data lake was created was because sort of technological limitations in the scalability and of data warehouse storage, and they lacked separation of storage and compute. Well, now those technical limitations are gone. They've been kind of obliterated. All the major data warehouses and databases, including SingleStore, have separation of storage and compute. And so you don't get a cost or storage advantage by having a data lake anymore. And it's a lot easier to to maintain and understand what you have in your data warehouse.
That's a really good insight. Yeah, this is I think it's going to be an exciting few years. There's just so much shakeup going on in the industry. But I just say it's we talk about data. There's also the transactional aspect, which is just sort of its own thing. This is. I don't know where it goes. So, and it's crazy because I talk to a lot of people, in the industry, like, people like yourself and stuff. And it's, I just, all I know is it's definitely not going to be what it is today. And so, but at the same time, I find it really interesting too, because a lot of the same problems that I've seen in data for 20 years are the same problems we're talking about now. And it's not really anything that has to do with technology. I guess talking about this with somebody a couple of weeks ago, but it's like trusting data, right? Like you get into a meeting, somebody asks, these numbers, are they right? This seems kind of off. Like that's still the same problems that we've had 20 plus years. And the tech gets better, but at the end of the day, there's definitely still some underlying things that I think still should be solved, and we're making progress for sure. But
Sure. And those problems are just getting bigger. Like I think because
yeah,
people are relying on, making big decisions based on data and KPIs and all these, and like if your data isn't exactly what you think it is and is not entirely trustworthy, then you're going to be making the wrong decisions. And then if you want software to make those decisions for you so that you can make them faster, then you're not even going to be able to know why you're doing the wrong thing.
yeah, sure. Just doing dumb things faster. So yeah, it's interesting. Yeah, kind of switching gears a bit, I mean, see you a lot, on social media. You're obviously, very high profile in the data world. But what do you do outside of, your working hours?
I do a lot of reading, and I try to stay active, try to stay fit. I used to be a runner, did a lot of marathons. Recently been doing rowing. But I think actually one thing that is sort of like my biggest defining thing is just I like to walk. And every weekend my wife and I usually we call it adventure lunch. We just sort of walk out the door and figure out what neighborhood to go to, and then figure out where to eat, spend a couple hours walking. Maybe it's just because I'm a little bit ADD, but I just sort of like to keep moving. And it's actually how I met my wife. As we were in college, and our dorm was the furthest away from campus, and there was a shuttle, and most people would take the shuttle. And she and I were the only ones that pretty much every day would walk. And I kind of saw her in these, her bright blue gloves, walking, trudging in the snow. And I'm like, this is an interesting person. And so we've always loved to walk, love to travel, and you go to a new city and, just spend the day walking. So I think that's sort of my number one, kind of distinguishing thing that I like to do.
How many steps do you think you get?
It depends, but I go we were just in New York a couple of weeks ago, and got 30,000 steps.
That's the best city for walking, by the way. Love walking there. Yeah, it's my favorite thing too. When I'm there, I just walk. There's not really a plan. Just go somewhere. Yeah, and your step count about reflects what I would be getting to. It's seriously, that's insane. So that's really cool. Do you do walking meetings?
Yes, that's actually, I love doing walking meetings. I used to be, when I was at Google, there was a path along the canal. And so basically do one-on-ones to just, you go and walk. And it's just a way of loosening things up, and you can talk about ideas more. And I think that's one thing actually that COVID has made more difficult, because you can't really, if you're not in the office, it's harder to meet up. But I still have had a couple of walking one-on-ones, and sometimes I'll take a meeting one-on-one on the phone, so I can actually walk and walk. And
talk. That's funny. I do that too. So that's awesome. Yeah, it's kind of weird. I think the art of walking, especially in America, is definitely one of those kind of lost arts in a way. I live in Salt Lake City, where it's probably the least walker friendly place, probably outside of Texas. Just name your city there. But where are you located right now?
I'm in Seattle.
Okay.
So nice. Seattle is quite a good walking city.
Mm-hmm.
But I lived in Texas for a couple of years, and my wife would sometimes walk to the grocery store, and people would think she was crazy. They would pull over and say, "Hey, do you need a ride?" Because it felt really bad for her, on foot. True, it was probably 110 degrees out, but it's a different place, and I usually when we travel, we like to go places that are walking places, like New York, like London, et cetera. But rather than going to the beach and kind of laying on the beach, you go a little bit crazy, at resorts where you can't necessarily go anywhere.
Yeah, I'm the same way. Like I don't like resorts at all. Like my dad, he used to live in Phuket on the beach there, and I was just like, it's fun for a couple of days. We're just bored senseless. So we'd go on walks actually all the time. We're running, along the kind of in the jungles around there, at least the roads around the jungles. You don't go to the jungle, you get hit by a cobra. Um, but yeah, it's one reason somebody was asking me why I live in Salt Lake, and it's like, well, it's a nice place because you can go trail running just like literally probably 5 minutes from the house. And you could probably go for about 100 miles if you wanted to, but or not. But yeah, it's interesting. I mean, I know personally, like I try and find locations where you can do a lot of physical activities. Just 'cause, I don't know if it's in like a constrained city, we can't do anything. It's just kind of go crazy. So that's interesting. Well, it's good to meet a fellow walker. Didn't know you're into that. So, well, awesome, man. I think coming up on time, but for people who want to learn more about you, how would they do that?
I'm on Twitter. On Twitter, my Twitter handle is just my name with the vowels taken out. And also, feel free to connect on LinkedIn. And yeah.
Cool. And SingleStore obviously is, I'm guessing singlestore.com or something. So
yeah, it's you can email me. I'm Tagani at singlestore.com.
Cool.
And happy to have people reach out.
Awesome. Well, it's been an honor having you on. Like I said, always been a big fan of your work. So it's a pleasure to talk to you. So
thanks so much. This was fun.
Yeah, thanks. All right. Thanks.